Okay. You want to start on the homework then?
You mean the group quiz?
We have to take the participation. Then, wait, which quiz can we do? We can't do the group meeting quiz together? Is that what it is?
We can do the group meeting quiz together, and the homework. We can do the homework assignment together.
We can't do the homework quiz together.
Right.
All right. Well, worst things that happen, I suppose. Let's do this.
So we could go through the homework assignment together.
We can.
Before we try to start the quiz, or if you feel comfortable with it, we could just do the quiz.
You want to do the group thing first?
Or you want to do the quiz first, the group quiz?
Oh, you mean go over a preparation assignment?
No, so we can actually do a group quiz together.
Yeah.
Yeah.
I'm saying the homework, we could go over the homework assignment together because that has an answer key, so we could check to see.
Oh, do that first?
If you want to, or if you feel good about this subject matter, we could just do the quiz.
It's stats. I never feel comfortable. Let's do the group thing first, and then this way it gives us time to think about how badly we need to practice together.
Do you mean the homework assignment?
I was thinking the group quiz.
Okay, so you just want to jump into the group quiz?
Yeah, I don't know. What do you think, Christy?
I don't think I have any questions from the preparation assignment. I don't know if anybody else does.
Okay, we can start the. We can start the group quiz then.
Okay.
Alright.
Are we sorry?
We're starting. Sorry.
No, I said, are we sorry? Are we sorry we committed to it?
No. Yes.
Wow.
Oh, maybe it just looks horrible. Let's see. Suppose we have a set of paired data. Let D equal X after and negative X before. So D is the sample mean difference.
Yeah.
I thought that was D bar. Or bar D, whatever. Oh, so it's just the difference. So the D equals the difference.
Yeah.
Okay, so the null hypothesis is 0. The alternative hypothesis is not equal to 0. And the population standard deviation is not known. Jordan collects a sample size of 9 and computes the sample mean difference to be...
Are we looking at the same one?
2.2.
Yeah.
Yeah. We are looking at the same one. Sorry.
That's okay. So the sample mean difference is 2.2 and the sample standard deviation of the difference is 3.3. What is the value of this test statistic?
It's a fantastic question.
So it's two-tailed, right?
Yes.
Because it's not equal to, it's just not equal to. We don't know the standard deviation, so it is a...
So it is a t-test.
Okay. and we have a difference. We have some data that is the difference between two groups. So it's 2t, right?
Yes.
Are we doing 2t times the standard deviation divided by the sample?
I'm not sure what we're doing because I don't know what the value of the test statistic. What does that mean?
I don't remember being asked that, but you know. Cool.
They like to just spring stuff on you, don't they?
I'm sorry, I'm not laughing at I'm laughing at the circumstances we put ourselves in. Like, we're actually paid to be tortured.
You're laughing so you don't cry, right?
Pretty much.
Yeah.
Pretty much.
Okay, so value of the test statistic.
Are we supposed to put this in a...
Oh, okay. I wrote down, I have some of my notes, I have compute the test statistic, and it's the t equals d minus 0 over s to the base power of d, however you say that, divided by the square root of n.
Okay, say that again?
It's... Wait, where is...
What's the sample deviation difference? Okay, so it's the difference minus 0 divided by the sample standard deviation of difference divided by the square root of n. Do you have that formula?
Yeah, do you know where that was in the homework?
It was kind of more at the beginning of my notes, so it's during the 6 steps. Did you watch that video?
Yeah.
He went through the 6 steps.
Yeah, let me look at those notes.
I think that's what I wrote it down from.
So there's a similar, it's the same formula that's on the online book. However, it doesn't give you the actual numbers.
So let's see if we have everything. We're trying to find t, so t equals d, which is we don't have that information. Do we have to solve for this?
I don't know how to do this.
Because we don't have the before and after data.
Mm-hmm. Did we miss a step in this?
So what is the test statistic? Which one represents the test statistic?
We don't have one that represents a test statistic.
I think we one of those things.
What's t-bar again?
T-bar is the sample mean difference, or the point estimate.
So wouldn't that be instead of...
Oh, maybe that's it. Maybe it's 2.2.
I think it's 2.2. Because then... Yeah.
Because but my formula doesn't have a D-bar, it's just a D.
Screw it, let's just try it. I don't think we have much to lose at this point.
Wait, it has to be in here. I think they're just asking which one of these represents the test statistic. Well,
yeah.
it's not none.
So in the video, it has d-bar. It's t equals d-bar minus 0. So that's what we need.
Okay, so it'd be 2.2, right?
Yes.
Okay. That's
Are
what
we-
I was thinking they were asking, but I
Oh, I can't see the rest of this formula.
are we all good with that?
Wait,
Um,
not yet. So can somebody? I can't look at the rest of it. The formula is like is pretty fuzzy. So it's d bar minus 0 over what?
over the sample standard deviation, the S with the base of a D. So that's 3.3. I'm just going to write this out with the formula and see. Is that what you're doing? See what it looks like? See what it comes up with?
Yeah, because I want to be able to look at it while I'm doing the math.
Okay. Okay, so then it's, sorry, stop in the middle of that. And that's divided by the square root of the sample size.
So,
Which is, the sample size is n.
Correct.
So it'll be s, like foot d, or the little sub d, over the square root of 9, or the square root of n. Correct?
Yeah.
Okay. And then did you do the math already, Christy? Is that what you said?
no.
Okay.
So I have 2.2 minus 0 over 3.3 divided by the square root of 9. Is that what you have?
Yes,
Yeah.
that's what I have.
Okay, so let me.
Okay. 2.2. Did you get 2.2?
I got 0.222222. Is that what you got?
I just got 2.2.
Oh, you got 2.2?
Yeah.
I'm going.
What?
Oh, I'm trying to. I did a calculation error, so I need to fix it. 1, 2 equals. I got 2. Am my numbers wrong? No, because 2.2 minus 0 would be 2.2. So you divide that. Okay, maybe we can do this differently.
2.2
3.3 divided by square root of 9. That's 1.1. So 2.2 divided by 1.1 would be 2. Am I doing my math wrong? It wouldn't be the first time that's happened.
Okay, we've all got a different answer. This is not good.
No, and I keep getting my answer. Maybe we need to do this together.
Okay.
I'm gonna do just the bottom part. Equals.
Right? Okay, so if we break it down, it does come out to a 2.
Does 2 sound like a probable answer?
What did you get?
Well, I got, when I did them separately, I got 2 as well. When I did it all together in a formula, I think it divided the 3.3 first, so.
So aren't we supposed to do parentheses over 3.3 divided by, and then parentheses again with the square
Yeah,
root?
I think I didn't get all the parentheses in there, but when I do it separate, yeah, the bottom comes out to 1.1, so.
Yeah, because I get 2 either way, whichever way I do it.
Yeah.
I got 2 as well.
So.
I just feel like this is like easier than we're doing it. Okay, well, let's move on.
So we're gonna go with 2?
Yeah, let's see. Okay, wait.
How many times have we gotten 2? I've gotten 2 probably 4 times out of 4.
What?
Oh, what's the probability of our answer giving 2? Because we tried it.
You need to increase your sample size, Eloise. No, I guess it just seems like a weird answer to just have 2. But if that's what we got, that's what we got.
Okay. Probability of being greater than 2 is. Oh, well, then it says the probability of being greater than 2.
Right, 2.
So then we have to put in that 0.0403 into our probability applet, right? And make it two-sided.
Yes, but we don't have any data.
Well, it's giving us the 0.0403, right? That's the probability.
Touche.
So you put that in here, right?
I think so. I follow.
So we're going to put the point, what is it? Tell me what it is. I'm on my other screen. 0.043. I think we're going to put that into the probability app. If I can do it correctly, it'll work.
Did they ever show us how to use the alternative hypothesis to get a p-value?
I'm trying to figure that out.
Step 1, state the known alternative hypothesis like we did in previous. Let's say so let's go through. So the suns have different heights than dad. So random sample of suns and dads was Q. So we want to see if there's step 1 step state the known hypothesis. All this step 2.
I think we're missing data.
Everything we done on this lesson was through like SPSS.
Oh, wait, hold on. So, wait, the question says, oh, it doesn't give us a. Never mind. I got excited. Because we put 0 in our equation because it is two-tailed. But I was wondering that if we had a different alternative hypothesis, actually, do we have to subtract it through 0.0 or 0.403? Does that make sense? Because they're changing our alternative hypothesis. They're changing it, instead of it's different to 0, they're saying that it's less than 0.403, right?
Is it possible we could subtract it from 1?
I don't know.
In fact, just here, the numbers for your results, but
I'll try it.
get that output. So that's a nice slide I have.
Okay. Oh, well, that's close. Okay, I subtracted 1 from you're meaning the 0.0403, right?
Yeah.
And I got 0.9597.
That's what I got too.
And when I put it into the two-tailed test,
Yeah.
I got, well, it automatically rounded,
Uh-huh.
but I got 0.9681. So, close to this. But it rounded it up for me. So, I think you put it into the applet, but it's rounding, so I'm not really sure why. I think that's the way you find it if you have the applet. Anyway. Okay. So I say we just do, because then if we round this one, it'd be 0. The 3 decimal places. So it'd be 0.60, right?
Yeah.
No. Would it be 0.60? Or 960?
Yeah.
And mine was 0.968. So this is terrible. I just feel like this isn't like what we did.
I agree.
So I have a question. If we have our test value, how do we find the p-value out of what we did? Because if they're trying to say if it's lower than 2, well, no, I have no idea. I have no idea what I'm talking about. Never mind.
Did you understand what Christy and I did with subtracting from 1?
No, please explain.
Because it can only be, there's only a chance of 1 probability, right?
Right.
So if it's greater than the 0.0403, then it can only be up to 1 that's those possibilities are.
Correct.
Probabilities are. I'm looking for something.
So that you just subtracted
From 1. We
and that's
subtracted
the
from
answer?
1.
And I put mine in the probability app and got a similar answer.
And she got close to the same answer, but not exactly the same answer.
Yeah, because it rounded it.
So if we I think it's a choice of going between just subtracting from 1 or using the probability applet. So I don't know.
Well, I'm going to use yours because mine rounded.
Okay.
But
So you're saying 0.960?
yeah.
Do you think we're Eloise, what do you think? Do you think we're close to?
I think so. It makes sense to me, but you subtracted 1 from
The probability of 0 0.0403. We subtracted that from 1.
And then you stuck it in the applet?
Well, Christy did both. Christy did both just to see what it would, just to compare.
Because
Yeah,
oh, go ahead.
I just stuck the 0.0403 into the applet as a two-tailed test.
Because I got 0.9597.
Yeah, and then you have to round to 3 places.
So 96. So is it 0.96? 0?
Yeah, that's what we're thinking, but I'm not feeling super confident that this is.
Yeah, how could anyone feel super confident about that? Ugh.
Well, why don't we move on and then see how we feel about it before we submit.
Okay. Okay, so for this next one, we just have to create a column of differences for this file. The chapter 12, data A.
So do you have that one? I'm gonna have to pull it up.
I'll pull it up. So, what else again? Column of differences. What is this? Okay.
Christy, I can't hear you.
You can't hear me?
Well, now I can.
Sorry, I wasn't facing my phone.
Oh, okay.
Okay, this is not even. It's not in the regular data files again.
Yeah, I can pull mine up.
For where? How did you do it?
I just opened it in a new tab from the SPSS files.
Really? Because I don't even see it on there.
Just be ready. Right below the cardiac arrest one, or the cause of death.
Is it data A
Yeah.
or data B?
Data A.
Data A?
Yeah.
See what I can do here. This one, it takes my computer a lot longer when I go through the textbook. Because I downloaded the whole file before, so that goes pretty fast. But if I have to go through the textbook, it takes a long time.
Yeah, it takes a little bit of download.
Hmm. Okay, I think I got it.
Okay. So then I think we're just doing the transform, right?
Yeah.
And then we put the target variable as distance.
Okay, so first we need the differences.
Yeah. And I'm doing group 2 minus group 1.
Okay.
I don't think that it matters. You just get either positive or negative. Okay. Then after we do that, we have to go into analyze, right?
Yes.
Descriptive statistics.
Yeah.
And
Isn't it analyze, compare, means? Oh no, never mind. It's because we're doing a double T.
yeah,
Okay.
we explore and then we put our different variable into the dependent list, right?
Oh,
And press OK. And then we should get all the answers. So what are they asking for?
We're looking for D bar.
Okay, so the D bar would be negative 31.0250, right?
I can't hear you.
Okay. So I don't know what you have, but I have negative 331.0250.
Yeah, mine sounds about right. Well, the same. What about you, Renee?
I'm still pulling up my data, sorry.
No, it's okay. We can.
So this is the t-test, right? That's what you...
No, not yet.
Oh, okay. What did you do?
I computed the differences, and then I went into analyze
Uh-huh.
and descriptive statistics and explore, and I put in my differences scenario, and then pressed OK, and then then it'll show me the values for the differences. So for D bar, which would be the mean for the differences, right?
Okay. So
31.0250.
that's just the mean, right? It says difference. It says the mean and it says difference off to the left.
Yeah. Mm-hmm.
Yeah, so I got negative 31.0250.
Yeah.
Is that what you got?
Yeah. And then, so I just put 31.025. Negative, whatever.
Mm-hmm.
And then for the standard deviation, you just go, which is the S little d thing. Look under the standard deviation, right?
Right.
Okay. So 341.157. Okay.
Did you get the same thing, Renee?
We're looking for the standard deviation of the difference.
Yeah.
Mm-hmm. Is that just listed as a standard deviation?
Yeah.
Because it's like 300.
Uh-huh.
Is that right?
Yeah.
When the mean is negative 31? Whoa. Okay. So I got 341.157.
Yeah, I'm pretty sure. Okay, then it asks for the test statistics. So this is where we go in and we change it to the T value. So you go into analyze.
Compare means.
Compare means, and then one sample or
No.
independent. No, what is it? One sample, right?
Yes.
Okay, so.
So the test negative.
Look at the statistic. Okay, so where are we finding that?
Okay, so did you get your sample t-test?
Yeah.
Okay, so then what's the question? I don't have it pulled up. Next question.
The question is what's the test statistic and what's the p-value?
Okay, so the test statistic is the t. which is
Oh, just
negative-
the, okay, under T.
Yeah.
So I got negative 0.407.
Yeah. And then the
Did you say
p-value.
negative 0.407?
Yeah.
Okay.
Negative.
Yeah.
Negative 0.407.
And is this a two-tailed test or a?
It's a two-tailed test.
Okay,
Yeah,
so
because
then
it's just not
two-tailed,
equal to.
Then that means we don't divide, right?
Yeah.
Correct.
So we just put in where it says sig two-tailed 0.689, right?
Uh-huh.
So
Yeah.
that would be our p-value.
Yep. And then our
You have 0.689?
Yeah.
Okay.
and then our alpha is 0.10, so our p-value is low. So we reject the null. Wait, no, it's higher. What am I thinking? It's higher.
Yeah.
So we fail to reject the null.
Yeah. Our p-value.
And so then it's asking us if it was one-tailed.
Okay, so if it's one-tailed, then we're going to divide, right?
Yep, by 2,
We're going to divide the 0.689.
which is oh, never mind. I'll let you finish it. I got excited. It's the one thing I can do.
Well, this is what I thought we would be going over. I'm like, yeah, I can do this. And I'm like, no, I can't. Okay.
It would still be higher than 0.05.
It's actually 0.10.
Oh, it is.
For this question is 0.10.
Oh, yeah. But it's still.
But it's still higher, so we fail to reject the null hypothesis again. Correct?
Yeah.
Okay.
Okay. Which is greater, N or DF? Now we have to go to 12B to answer these questions.
Oh, yeah.
No!
Are you okay?
If they expect us to switch around so much, they really should just have a link.
Yeah, I agree.
That'd be nice. Okay, so compare the data.
I gotta.
So I did something silly.
Uh-oh.
Yeah. My SPSS expired, so I had to re-put the code in. And I thought I had saved it, and I remember that I had it on a sticky note, like one of those type of electronic sticky notes on your desktop. And now I have a flashback of thinking that I might have deleted it. So I'm like, I don't want to pay the $11 to renew my SPSS. It's kind of really annoying. So I'm just like, and I keep thinking, did I delete the sticky note? Is that the only place where it was?
Well, I think it's pretty crummy of them to suddenly just, like mine. I thought I bought it for 6 months, but it was saying, oh, your password's going to expire. So if you want it, like if I wanted to reinstall it or something like that, I couldn't. It's like, well, if I buy it for 6 months, then I should have full access for 6 months.
Well, you do have full access, but you have to keep the key, like the code that you put in there. And so if you keep the code, then you don't have a problem. You can just continually put it on.
Well, why? If I bought the dumb thing, it should just work, right?
I agree. I agree. It's dumb. So I think I'm just going to do my homework and prepare for the quiz. I don't want to pay $11, so I'm just going to do it at the library where they have all the programs.
Oh, really? You can just use it there?
Mm-hmm.
Oh, well, that's nice.
For this one, are we doing the test value again?
Wait, what?
Are we doing the test value?
So,
Sorry, I haven't even downloaded this thing. Let me.
so, which one's greater? Yeah, you would be doing the test value.
This is a lot of work.
But I don't understand why that has anything to do like with the degrees of freedom and the sample size. Like, why would you want to know which one's greater? Does that make sense?
Yeah, what does that got to do with anything?
Yeah, like, okay, so I know which one's which. Like, I don't know why.
Now I've got both of these open. I'm going to get confused. Which one's which?
I closed my other one.
I should have, but I just... Wow. Okay.
Did anybody get it yet?
I think I'm going to have to close this other one out. It's not... It's throwing it all into one thing.
Questions are there?
Okay, one more time. Let's see. We're just doing the t-test, right?
Yes.
Yeah. Well, we still have to go in and subtract, right? Or not?
No, you don't have to subtract. Well, let me check.
Just make a column of differences.
So, no, I don't think it's not like asking you to do a difference. It's just which one's greater, the sample size or the degrees of freedom.
Okay, for mine, the degrees of freedom is 21.
Yeah, that's what I got.
And
what's
the sample is that T?
No, that's N.
N?
Sample.
Oh, sample.
I got 22 for the sample.
Okay, yeah, I got 22 for N. N says 22, and DF says 21. Well, the sample size is higher.
Yeah. And then it says it's a two-cell test with a significance level of 0.01, so I gotta find the p-value and see what it
So the p-value should be on the same thing too. And it's not, it's single, it's double or two-tailed, so it should be there already.
Yeah, so the p-value is 0.001. So
That's what I got too.
0.001.
That's what I got too. Yeah.
Okay.
Okay, so we're going to reject the null, right?
We weren't told.
On
What
13.
decision have you made?
No, we weren't told what
Supposed to be
the
making the decision.
we weren't told what the alpha would be.
Yeah, it's this level of significance is 0.01.
Oh, ha ha ha. Yeah, you're right. Sorry.
It's okay.
Thank you. I'm glad you're here. Oh, goodness. I don't know how I passed my classes. So we reject the null.
Yeah.
I
So,
think we're supposed to assume it's 0.05 unless they say otherwise, right?
yeah.
Yes.
Okay, 14.
You decided to try another alternative hypothesis. This will tell you use null hypothesis is greater than 0 and you keep the same level of significance if the p-value increase or decrease. The p-value will decrease.
Because we're dividing it in half,
Yep.
because it's not two-tailed.
Right. And we reject the null hypothesis again.
Right?
Right.
Yeah.
It sounds
Okay.
right to me. It sounds like too easy. Like, it worries me.
Yeah. I agree.
All right, well.
We're all gonna see our boat. We're all in the same boat, and it's all gonna go down together.
Yeah.
Well, ladies, it's been a pleasure.
Which alternative hypothesis will give the smallest p-value? If we don't have information,
As we have seen, the p-value depends on the alternative hypothesis. Setting aside the data in this problem, do you think the general rule can be made which alternative hypothesis will give the smallest p-value? What kind of question is this?
I think we need more information.
I would agree.
Well, wouldn't those two come out the same though?
Yep.
The greater than or less than would be the same. They'd be equal to each other. They'd both be smaller than a two-tailed, than a not equal to, but they would be the same. I think.
Okay, but we can't mark both.
Yeah, we can mark both, so I would go with not enough information because of the problem.
Right?
Okay.
That makes logical sense to me.
Who's gonna turn this in?
Oh man.
I submitted it in twice now.
Okay, I'll turn mine in.
You're a trooper, Christy.
I'm probably getting the lowest grade in the class because of my last test.
What grade do you have right now?
She's going for the sympathy vote.
Yeah, I'm getting an 85 right now.
Oh, come on.
Okay, determine the confidence interval for the mean difference between the two groups. What?
Are we still using the same information?
Yes.
What?
So it says determine the 95% confidence interval for the mean difference between the two groups, which is a lower bound. So I'm guessing, let's see. Why doesn't it just...
Is it
We have that information. We have the 95% confidence interval is the gosh, can't think of.
Oh yeah.
But it always
Yeah.
it's the fallback, the standard one. So
The t-test.
So
Wait, no. Hold on. Yeah, that would be, because if we're trying to do the confidence interval, then we would be putting 0, right, in the t-test for the test value.
Yeah, but they want a 95%, and it's already set at 95%.
So then we should be okay.
Yeah.
Okay.
Right?
Right.
Okay.
So our lower bound.
Okay. So negative 18.6065.
Negative 18, what?
0.6065, so negative 18.067.
I got negative 18.607.
Yeah.
Is that what you got?
Yes.
Okay. And then our upper bound?
Wait, that was our lower bound, right?
Right.
Our upper bound, negative
I got
5.
negative 5.303.
Yeah.
Okay. That sounds about right.
Oh my gosh, I don't want to turn this in.
I
Well,
can
are
do it
we,
again if you really want to.
should we go over 3 and 4 again? Are we sticking with what we got on 3 and 4?
Yeah, we are. I just don't see how else to solve that.
Hey, fine.
Like, I'm pretty sure 2 is right. Or 3 is right, but what do you do for 4? And 4 sounds pretty, I don't know. I'm going to submit it. It's okay, Chrissy. You don't have to do it. Hey. Well, 4 is wrong.